Okay, welcome. It's mock time again. I seem to have put together hundreds of these component 3 mocks. Will you just learn it and then we don't need to keep retesting and weighing the pig? So, exam time. I've got a pencil, I've got a pen, I've got a ruler, and I've got a calculator because you need all of those things when you are doing an exam. I have an additional pencil sharpener, look at that. It's the best pencil sharpener in the world, that. So, without further ado, let's go for question 1. So this is from one of the older style papers. Nevertheless, it is testing. So, it tells us that we've got a transverse section of a spinal cord and its associated reflex arc, which of course is these neurons going around here. And oh look, I've been brought a rubber. Woo!
You never know.
You never know, I might make a mistake. So, first thing, just identify, this is straightforward from your knowledge and an explanation. So we've got 2 things to identify and we've got to do an explanation. So effectively it's going to be 1 mark for the 2 things you identify and then an explanation of, what are we explaining? Explain why they're different colours. So, X, helpfully coloured white, is going to be white matter. That's good, isn't it, that they've coloured them the right colours. And this one's helpfully coloured grey, so that would be grey matter. So, this is your kind of easy starter question. So that together would be 1 mark. And then your explanation of why they're different colours, this is where you've got to go into a bit more detail. So, because. Explaining. Because grey matter, what do we know about grey matter? Is cell bodies and nuclei. And we're doing a difference, we need to say something about each. And white is myelin. Identify L and Z. Where are we looking? L, big bulge, dead giveaway, dorsal root ganglion. Spell root correctly as well. It's not root as in I'm en route to. And what else are we looking for? Z. Z's that little blob in the middle. Central canal. Oh, I haven't written all summer. It's a bit disturbing. Okay, then we've got part B and we've got 1 and 2. What is the name given to the cells which partly cover the neurons and the material? So I think when you're talking about covering neurons and covering axons, your first instinct is to write something about myelin, but that's a material. So we're going to put myelin there. And the cells, of course, are the aptly named Schwann cells. Oh, I love that. The other double N, of course. So, here we now, we're getting to the nitty-gritty of it. What is the function of this material? So what's the function of that you just named in the conduction of an action potential? So what do we know about myelin? We've got those nodes of Ranvier and we've got saltatory conduction between the nodes. So the conduction of an action potential, so conduction is saltatory. And again, please be careful with the spelling of that. It's saltatory. Peel them first, obviously. Which speeds up the transmission. And again, it's really tempting to just put off the nerve impulse, but it's asking about action potentials. The action potentials. Okay, so here we go, off onto the applications. Multiple sclerosis is a progressive degenerative disease of the nervous system in which the material referred to in B1, it's not going to tell you what it is because you've answered it and got a mark for it, is destroyed. So we've got no myelin, is what they're saying, or less myelin maybe. Symptoms include increasing muscle weakness and loss of vision. Suggest, that means there's more than one right answer, an explanation. Now obviously it means there's more than one right answer, but they've got to be actually, based on what you know. So, first thing we can say about no myelin is the opposite of that. So there is a saltatory conduction, cannot happen. Without myelin. So that's, that's definitely, you're saying you're doing a sort of description then. And then you need to do a bit of thinking. So how could that cause muscle weakness? So it might be that the reduction in speed means the impulse doesn't get to the muscle fast enough, or doesn't get to the eye fast enough. So an explanation, we're going to use a so word this time. So action potentials are conducted more slowly and may not reach muscle cells, causing weakness. Or you could put might not reach the retina, or might not reach the brain. Weaking? What's that? Weak. No, I said I wasn't going to make a mistake, but that's not true, is it? So there we go. Suggest a possible medical treatment for multiple sclerosis. So obviously if it's causing a destruction of the myelin, we need to replace that. How could we do that? Well, we've all heard of stem cells. So use stem cell treatment to remyelinate. And if you'd said replace the myelin, that would be also obviously fine. So turning over, because we've not got to the end, here we've got a picture. Nerve nets are common in some animal groups. Complete the diagram to show a nerve net as it would be seen in Hydra. 1 mark. So this is obviously a cross section showing some layers of the Hydra, and I don't want to waste hours sort of doing this beautiful diagram. My understanding of a nerve net is it looks like a net. So I'm just going to do that. If at the end you're bored, instead of colouring in the letters, you could make it nice and put some cells around it. You won't be. Give 2 ways in which the nerve net differs from that of the nervous system of a vertebrate. Now in your notes you have got a table that compares nerve nets to vertebrate things. I'd just pick, I don't know, 2 or 3 of those things. So these are my top 2, the ones that I think, are really easy to remember. So again, we're doing a differs, say something about each. So vertebrates have 3 types of neuron. And Hydra have 1. And my other one is that you've got action potentials going in all directions on this. So invertebrates, action potentials, are conducted in one direction and more directions, or any direction, or more than one direction in a nerve net. Okay, job's a good one.